let's get started. We're just at 5 o'clock here, so we're still on time. I'm up here today to talk about network effects and why base sequencing is important. So this is sequencing day. You guys have heard about all sorts of sequencing things, shared sequencing, coordinated sequencing, and kind of the umbrella I use. And today I'm going to talk about specifically base sequencing and why I believe in practice base sequencing is significantly more practical than a form of shared sequencing that is not based. I'm M-Team, or Matthew. I co-found Spire Labs. We build the best base roll-ups. If you want your own base app chain, come talk to me after the talk. So first of all, just some quick expectations for this talk. We're going to go through 5 kind of general things. We're going to talk about what are network effects, get into some of the nitty-gritty there, get into details about Ethereum's network effects. So we're going to go through things like developers and also things like liquidity, all the things that you hear people like list when they give a long list of network effects. But we're actually going to talk about like the practical details. We're also going to talk about parallel innovation, which is something I believe is absolutely fundamental to the success of Ethereum compared to a monolithic alt layer 1. And I really do want to make this point. Parallel innovation is absolutely key. The other thing I want to get into is a little more on the technical side, which is, of course, coordinated sequencing and exactly what coordinated sequencing can do for the ecosystem that we all care about here. And then finally, we're going to talk a little bit about infinite games, and I didn't want to put endgame there, but really what the endgame I think will look like. So yeah, just kind of general vibes for this talk. It's going to be non-technical, good vibes, not hitting on anyone. If you have any questions about implementation details, about the research that Spire has been doing, feel free to contact me. My Twitter will be up here at the end, and you can also just talk to me in person. I love to have conversations. So first, let's kind of define network effects, because I think this is something that we hear quite a bit in these presentations, in research proposals, and on Twitter. And I want to just get like really clear, what is network effects? My personal definition is anything that make a certain network more valuable than another. These effects are correlated with the growth or size of the network. As you guys might have heard Metcalfe's law. One thing I just want to like drill home here is that we care about users, super important. We care about liquidity. This is fundamental to giving users good execution. We also care about infra, so all of the off-chain infrastructure and on-chain infrastructure that makes developers' lives easier, which is where we get into developer tooling and support. So developer tooling would be something like Foundry, the Solidity language, so on and so forth, and support, right? That would be like the Forge Telegram channel or the various discords for Ethereum blockchain development. Things that other ecosystems, quite frankly, don't have, and you don't miss it until you don't have it, trust me. The other thing I want to talk about is state. So if your blockchain has been around for a long time, there's a lot of like kind of dead state that doesn't get touched anymore. But this does form an important part of people's identity. So I bet a bunch of us in this room traded NFTs at some point. Maybe you still have a couple of those lying around in your wallet. You haven't touched those in 2 years, but they still form a part of you. So migrating to another chain would require leaving that identity behind. So first of all, network effects are scattered. They are not present only on one chain, but rather present on multiple chains, multiple ecosystems. And I believe this is a problem, maybe not as much as a problem as some people who are selling solutions would set out, but it's something that we do need to evaluate. So first of all, right about this slide, network effects are a very clear thing that we can define. Like there are numbers that we can put down on paper, but there's also a lot of vibes going on here, right? This is kind of the Twitter ratios, the community, the kind of the events that are happening at Devcon. These are all important things to network effects that are much harder to quantify, but they're usually very strongly correlated to quantifiable versions of network effects, like on-chain data. So let's get into some of those. First of all, stablecoins. Ethereum, 51% of issued stablecoins, Tron 33%. You can find Solana somewhere up there at 2.15%. I believe stablecoins are important to network effects because they facilitate on-chain finance, right? Not necessarily DeFi if they're centralized stablecoins, but some form of on-chain finance, open finance, permissionless finance. I think that's important. Another thing is TVL. So you might see these charts all over the place. And I think it doesn't often get highlighted how massive Ethereum is when it comes to TVL. That's 55% of every chain ever. 55% of that TVL is on Ethereum layer 1. developers. So Electric Capital put out this excellent report, and I highly encourage you to go read it through yourself. I'm looking forward to the 2024 one, but this is the 2023 report. And we get into some somewhat interesting information. So one thing that I actually care a lot about is like onboarding new developers, and the way that developers who, maybe they know Python, right? They're fresh out of college. The way that they learn about blockchain is Google. None of us in this room are going to be learning the future of blockchain development from Google searches, but that is what new developers do. That's what they're used to, because that's what kind of trad tech does, right? You learn from Google, you learn from YouTube. There is minimal SEO optimization. By far, like if you want to get into blockchain, the top 10 results on Google are going to be Ethereum and EVM related, and that will, I believe, continue to see the increase in new developers to EVM ecosystem. Another thing is contract innovation. This is one of my favorite statistics. 71% of contract code is initially deployed on Ethereum. This does not include non-EVM chains, it's all EVM chains. But I think it's much harder to compare on SVM, of course. But for Ethereum, you'll see we have this 71% number. We have a few smaller chains here. Obviously, BNB has a chunk of that logic. Polygon has 7%, and every other chain has rounds to zero, right? There is still, contrary to what you'll hear on Twitter, quite a bit of contract innovation taking place on Ethereum Layer 1. There's also quite a bit of app dispersion from and to Layer 1. So when you create contract logic on Layer 1, it's most likely that that contract logic eventually finds its way to BNB, to Polygon, or to one of these smaller 4 Layer 2s, or of course to other places on Ethereum. Now, Ethereum, you can see here, is by far and away the place where that contract code initially comes from. There's also a huge network effect related to research and developer community. So I have some faces up here. I wasn't picky with these. I just picked people I know and appreciate. This QR code will take you to the Protocol Guild list. We have a ton of tools. We have a ton of dedicated developer and researcher kind of guilds, Protocol Guild obviously being the most notable, and then some resource organizations that give the Ethereum research and development community a massive leg up over any ecosystem. I encourage you to try and find research about Solana MCP. I'm pretty sure the best resource is still a podcast with Max Resnick. Ethereum is for developers. So we also have, this goes back to a previous slide, we have a lot of developer tooling. This is from the excellent opening talk at Devcon, and one that, this slide I think really captures a lot about the Ethereum ecosystem. You look up here, pretty sure everything up here is open source. Don't fact check me on that, maybe not Etherscan. I encourage you guys to go try contributing just 1 or 2 commits to these open source ecosystems, and I think you'll understand very quickly that this is a network effect. There's a tangible, valuable network effect to having all of this open source developer community built around the EVM and Ethereum ecosystem. Now, one other thing that we can look at is the native asset ETH. So yeah, the ticker is ETH, blah, blah, blah. But ETH is also permissionless money. Mike Nutter had a great talk on that at Devcon. I recommend you check it out. Ethereum does not have any Visa E unlocks yet, unlike some other chains, wink, wink. And also has a actually reasonable issuance policy. This is maybe a hot take. I don't think we need to change the issuance policy urgently, like some other chains do. I think it probably needs an upgrade at some point, but we're working fine with what we have. I think there's a tendency sometimes to look at the kind of vibes-based Twitter kind of perception of the popularity of different chains and ecosystems. But if you just look at the numbers, Ethereum is wildly ahead of Solana on market cap, wildly ahead on open interest, and additionally wildly ahead on volume. This is all centralized exchange data, so it does not include centralized exchanges. Now, one other thing about Ethereum that you won't find in all layer 1s or competing ecosystems is researchers and core devs distributed around the world. This makes it really hard to schedule calls, of course, and to coordinate, but it's, I think, really important to not only continuing to improve and grow Ethereum, but also doing this improvement in places that might not have access to the kind of like close-knit in-person communities that some of us do have. I was at a small event, EIP Fun, with some members of the Chinese Ethereum community, and they gave me some great anecdotes about translating Ethereum research into Chinese for Chinese enthusiasts and researchers. What they say is that the Chinese speaking research community is usually about 6 months behind the kind of tip of the chain, the Ethereum English speaking research community. And that's because the translation community and tools that we have set up are just not operating at the capacity that we need them to disseminate this information and build that conversation in real time. I think that is an absolute tragedy, something that we should improve, but also 10 times better than Solana. The other thing about Ethereum is global community events. I know this because I'm in Thailand. I've never been to Asia before. And I think you'll have a special taste of Ethereum when you go to a country like Thailand. And you meet people who maybe live in Thailand, maybe live in Asia. You really don't get this in other alt layer 1 communities. It takes time, it takes maturity to build. So what does all that mean? I talked about network effects. Ethereum layer 1 has a lot of network effects. How can we take this to the next level? One thing I firmly believe is that monolithic innovation will always be slower than parallel innovation. This is the core bet of the modular ecosystem. So parallel innovation is multiple teams, multiple people, and kind of distinct entities from a economic and financial standpoint that have their own goals, unassociated goals. I believe this type of innovation will lead to advancements further, right? This is like the basic parallelization problem. You can do more if you distribute. Now, parallel innovation is like a nice topic. I can come up here and say it sounds nice, but unfortunately we will lose on parallel innovation because every form of parallel innovation that we have tried until today in Ethereum has resulted in parallel network effects. And we call parallel network effects by a different name, which is fragmentation. The introduction of parallel innovation across layer 2s has directly led to fragmentation of liquidity, users, developers, new apps, ecosystem, et cetera, across those layer 2 ecosystems. I don't think that's necessarily the end of the world. Might not be a bad thing, but we have the very real network effect of Ethereum layer 1. We just saw some slides for that. And we, quite frankly, do not have anything like that on any layer 2. And so I think it is a absolute travesty that a lot of our efforts around fragmentation have focused on coordinating layer 2s and not involving the layer 1. That's really annoying. Here's what I want to see happen. Over here on the left, we have innovation happening in parallel and network effects happening in parallel, right? Fragmented network effects. We defined network effects a second ago, but it's all of these things that are really, really important to making a network valuable, the kind of things that VCs care about when they do calls with you. And you can see up here, of course, each of these network effects are going to differ, right? A new layer 2 is going to have much lower network effects than a large established layer 2. That puts them at a competitive disadvantage and limits how successful even their much better innovation could be. So you could have exceptional innovation on your VM. You could have a whole host of users that are super interested in your application, but there's not the oracles, right? The infra to support that. We need those network effects. Over here on the right, here's what I want to see. This is what I call parallel innovation. Network effects, Ethereum layer 1, and innovation taking place in parallel from teams coordinating at some points on shared standards, but ultimately building on top of the same network effects as the foundation for their protocols. So here's a question you have to answer if you're building a shared sequencer or any non-based sequencing, which is why start over if we already have network effect of Ethereum layer 1. You might not believe me that Ethereum layer 1 network effect is really good. We can talk about that afterwards. I think a lot of people don't realize that it's actually not too technically difficult to use Ethereum's network effects. In fact, we have Tycho live today, a base rollup that doesn't use Ethereum's network effect, but the foundations are there. They have some proof points for a couple months of how we can do something like based sequencing and eventually use this to recapture some network effects. So how do we do it? That is the big question, of course. The question we're trying to answer is how do we extend layer 1 network effects to layer 2s innovating in parallel? And this is not some deposit and withdraw type scheme where you have to wait 7 days. This is like real extension, right? Solana people will call it a network extension. I want that for crypto, but I think for Ethereum at least, I think the framing of network extension is like really misleading, and we should avoid that. But we do want to extend the network, and specifically the network effects of Ethereum layer 1. So how do we do that? Coordinated sequencing is absolutely key. Because you need coordinated sequencing to do coordinated proving, and you need coordinated proving to do synchronous composability. People at Espresso, for example, will disagree with me that that synchronous composability is actually very useful. I think in practice, they're missing one key point, which is that the only way to get an indistinguishable developer and user experience to global shared state is to have synchronous composability. Once you get down to like the one block kind of range, it looks and feels exactly the same. Developers can copy and paste their code from layer 1. Users can use the exact same wallet. Everything, all the off-chain infra works exactly the same. The only difference is that you have the ability to exit at some point. You have sovereignty and customizability, expressivity, et cetera, et cetera. But we need some tech to get there. One of that is real-time or fast proving. Unfortunately, without real-time proving or fast proving, we cannot get atomic cross-chain contract calls, which are required for arbitrage, for effective arbitrage at least, because you need those to do flash loans, right? And flash loans are fundamental to enabling a wider set of arbitrage opportunities and efficiently arbitraging to markets across domains. Unfortunately, you also can't use funds in the bridge contract to do something atomically on layer 1. You could do an asynchronous message passing, but those funds in layer 1, when they're in the bridge contract, you need to get those out somehow, need to use those on layer 1. So you can do asynchronous message passing really well for just layer 2s, but if you ever want to like really touch the layer 1, either the bridge contract or layer 1 liquidity with flash loans, you need synchronous composability. But you can still do some very valuable things without real-time proving. You can do atomic inclusion and atomic execution with promises from a sequencer that are atomic because of shared settlement. You can also do useful things for settling intents, right? You can make promises to do like cross-chain bridging or cross-chain value transfer. Although sometimes it's very important to have heavy collateral requirements. You might want to spin up your own network to get rid of some of those yourself, but it's going to be a little bit more painful. It's going to be a lot more complicated for developers. Raise your hand if you've ever tried building a synchronous application. So this is Python, this is JavaScript. There's a lot of apps. Raise your hand. Anyone? Synchronous application. All right, a couple of us. What about an asynchronous application? All right, well, if you raise your hand both times, then you can tell me that it is about 10 times more difficult to build something asynchronous. Rust, everything like feels asynchronous, even if it's not always, because people like to use like best async practices, even for sync programming, and it's really difficult. It is incredibly complex for new developers, and in the context of blockchain, where you're not just dealing with messages that have no value, you're dealing with incredible amounts of financial value, sometimes millions of dollars in one transaction. It's absolutely key to minimize that developer complexity, because the more complexity, the more security risk. But after we do have real-time proving, we can do some very powerful things. Real-time proving is required to flash loan layer 1 liquidity. This means you don't need migration. So all the funds in Balancer, arbitrage bots use those all the time for flash loans and arbitrage on Ethereum layer 1 to do DEX-to-DEX arbitrage. You'd be able to use this directly for arbitraging DEXs on layer 2s. I think that is super important. That means you don't need to migrate that liquidity. I don't think people really know why there's still liquidity on Balancer, but we wouldn't have to migrate it anyway. There's also, this is also the only way to recreate a monolithic developer experience of just being on one chain. Everything just works. Copy and paste. This is what I'm selling. You copy and paste your Ethereum layer 1 application, put it on a layer 2, and everything just works, right? You're interfacing with Aave, that just works. You'd like to connect to an Ethereum pool, get access to that liquidity, it just freaking works. I think that would be amazing as a developer. Now, there's also a extremely practical cost-saving thing that we can do by like sharing everything. I had a talk at Devcon about this. We can aggregate proving. That makes our proving costs go down, our proving unit costs. Share deposits. This means when we touch layer 1, it's cheaper for all of the rollups involved. We can do interop without ever touching layer 1 between base rollups. And then, of course, batch to layer 1 interactions. So if there's like 3 people trying to get a flash loan at the same time, you can just do the flash loan once and then give it to them 3 times. I think that is already a huge cost-saving measure. On the right side, I have a diagram of fast or real-time proving with shared deposits. Everything just kind of wraps up nicely into one snark that we can verify. All right, so let's talk about something a little bit more technical, which is synchronous versus asynchronous composability. There are trade-offs everywhere. I believe synchronous is much nicer for developers, much nicer for users, a little bit more difficult. And let's talk about why. So synchronous composability is the paradigm used in almost every blockchain application that you've ever used. Every layer 1 app uses the blockchain paradigm of synchronous composability. Almost all developer tooling, so Foundry, Forge, Solidity, all of the above use compilers and blockchain systems that are specially built for synchronous composability. They expect everything to be on one chain. Message passing does not work for the Forge compiler, all right? You have to relearn things. You have to reteach developers. All of the YouTube videos that we have on how to write Solidity smart contracts are basically useless because async message passing is just so different than synchronous atomic contract calls. Existing contract logic. So people don't understand, like, you can't just go and tweak Uniswap a little bit. You also have to re-audit all of Uniswap, right? It is not trivial at all to just drop synchronous composability and throw in some async composability. You need to re-audit everything. You need to make sure your auditors actually understand the security implications of the message passing protocol that you use, and that is really painful, really painful. We have 8 years of contracts built up on layer 1, and I don't think migrating those is a good idea. Significant existing liquidity is also built around this network effect, flash loans. There are millions, billions of dollars that are available for flash loans on layer 1. We can debate about how useful that actually is to arbitrageurs, especially if you have some more centralized systems of block building. But in this current day and age, we do see quite a bit of usage through flash loan providers. If we included flash loans in volume, then we would be destroying TradFi and Solana and Visa combined on these metrics. Now, I also believe that whatever you do to abstract things, you can rewrite your programming language. You can build things like chain abstraction to make that easier for our user. I believe that synchronous composability will always be conceptually simple because when you make a contract call, you get a result back. There is no message passing. You're not waiting for a message. Right, so in summary, it depends on the tech. If we have real-time proving, things look a lot different than if we don't. So let's kind of start over. What do we want? We want to build a strong central network effect that enables the things like execution efficiency to be kind of like a organization and coordination layer for apps, infra, et cetera, right? If you want to deploy an Oracle, you deploy that on layer 1, and every based rollup can use it. We also want efficient, effective, and most importantly, practical ways to use that network effect. I do not believe something like Espresso is a practical way to use that network effect because of that asynchronicity property. One additional thing here is permissionless incredible ways. I also think are incredibly important here. We can have parallel innovation, but if we just have Optimism and Arbitrum and Scroll and zkSync working on that parallel innovation, I don't think we have truly extended the network effects of Ethereum, which is itself, of course, permissionless. All right, so I've done a lot of talking up here so far, and I just have a couple more minutes. And so I want you to just close your eyes for a second and suspend your disbelief. Imagine if we did it. Imagine if we had synchronous composability. Imagine if we were able to effectively and practically extend the network effect of layer 1 to layer 2s and encourage parallel innovation. Here's what we have. We have harmony. We have composability with sovereignty. We give base rollups the ability to customize and specialize everything. This is their execution environment. This is their gas fees, right? They can add their token into the governance model, the upgrade process. And we also have balance, right? We have some things going on in the layer 1, some things going on in the layer 2, which gives us lots and lots of scale. All of the rollups that have opted into such a system will grow the pie for every other rollup. This means that not only do we use the network effect of Ethereum, we also grow the network effect of Ethereum. Better for everyone. So I think the end game is this: coordinated proof aggregation and seamless, that's bolded because it's really important, composability with customizability and sovereignty. That means synchronous. How do we get there? I believe base sequencing is an important step, at least why Ethereum layer 1 has such a strong network effect that we talked about in the beginning of the presentation. And building just straight up compatibility with existing network effects, of course, and developers. That's a key part of base sequencing. If we don't have that, then I think base sequencing is pretty much pointless. One important step is as fast as possible proof generation. So there's like 4 or 5 legit teams working on this. And I do believe that whoever, whatever coordination project, whatever intra project gets to this tech first will win. Chain abstraction, I think, is helpful. Not as valuable and probably a lot more complicated than people will tell you, but useful. This has been my presentation. Stay based.
All right. Okay. Thanks, Matthew. I'll take the first question, and then so raise your hand if you have questions as well. So first, I'm going to preface my question by saying that you referenced espresso incorrectly a few times in your talk. But you know, to clarify, like I think we agree with you, or I'll speak for myself. Like I agree with you that synchronous composability is a powerful thing, and it's actually something that you know, Espresso is being built to enable as well. Espresso is building this, you know, confirmation layer that, and it has this protocol circ that would enable synchronous composability even between rollups that are not based rollups that are just normal L2s on top of Ethereum. However, like I think maybe you were referencing a discussion that we had earlier, where the question that I posed was, you know, for all of us to consider is, you know, synchronous composability obviously is closer to the semantics of how applications are written today. How many applications of tremendous value are really out there for, you know, rollups to decide to become base rollups given the trade-offs, right? You know, will it really drive that network effect or not? And I think that requires us to sort of look at, you know, what exactly is the challenge of rewriting applications to work in an asynchronous model? Are there actually many applications that do a lot of function calls? The basic operations of sending money, trading or swapping in a DEX, they don't require synchronous composability. They can operate in an asynchronous system. So I thought you had some really good thoughts on that, though. So maybe if you want to share some of them here.
Sure. So first of all, I apologize for strawmanning Espresso at some point. My
no, it's all good.
conceptual understanding of Espresso changes quite a bit over time as I learn more and, you know, more research is released for the public. To kind of directly answer your question, I believe that synchronous composability is, like I said, the only way to get like truly seamless like developer and user experience. And it's possible to approximate this with asynchronous composability. I don't disagree with that, right? We can redesign our applications a little bit, tweak things. I believe that we can get to a stage where it's very similar. But I do believe that if we actually want to reuse layer 1's network effects, which is entirely based right now on the synchronous composability programming model, a lot of that liquidity is tied in like flash loan contracts that have synchronous composability as like a understanding of the EVM. I believe that will be, you know, a significant percentage of applications. To your question around like network effects and base rollups, I'd love to hear what the trade-offs of base rollups are that you're thinking about here. You're specifically referencing. I'd love to talk about that after this talk, you know, just face to face. I think we will see a lot more applications choosing to become based after considering the trade-offs that are available, not only because of the short-term trade-offs and some of the you know, ongoing research, but also because I think we have pretty strong community and researcher support from people like Justin Drake and Vitalik that base rollups are very likely a significant part of the end game.
Cool. All right, we have a question there in the back. Oh, wait, do you mind?
Hey, I have a comment/question which I would be happy to continue also discussing outside of this room, but maybe I'll start with a comment. So you were saying about the Uniswap and the composability, and actually now they are taking the roadmap of becoming a layer 2, which will be not a based rollup. So kind of they are taking a decision that goes a bit in the opposite way of what you're talking about, and to me, this is also an indication that there is some drawback of based rollups, or some positive thing of, let's say, centralized sequencing. So my question would be then, what you are? I would say you are very positive about based rollups and composability, but could you also speak a bit more to the challenges and let's say the hardships that maybe motivate teams like Uniswap, which I have no doubt that they know what they're doing, to go for a different design solution, or do you think that they actually make a mistake?
Well, yes, I think Unichain is a poor idea. I know Justin Drake agrees with me. I think Unichain and kind of their TE sequencer design with flash blocks is exceptionally interesting. like it's cool, but it has the unfortunate downside that they're like completely isolating themselves from the network effects of Ethereum. Now, we'll see long term, does that end up being a problem for them? Maybe not, because Uniswap does have a lot of their own network effects, like their massive application. It's very possible that that is a commercial success for them. I don't believe it'll be good for Ethereum, and I also don't believe it really encourages parallel innovation at all. When it comes specifically to like the trade-offs of base sequencing more generally, I think a lot of these discussions get down to timeframes. So it depends on the technology, it depends on layer 1 slot times, it depends on pre-confirmation protocols, their complexity, and kind of the associated research with that. I can give you a few of like the strongest tailmans. The first is that like base sequencing is strictly more expensive than centralized sequencing. Like everything that you need to do for centralized sequencing, you also need to do for base sequencing, except you also need to talk to the layer 1 at some point. It doesn't have to be much more expensive, but like at the limit, it will be more expensive. One other strong concern I've heard is that base rollups are not like all built by one company, and there are like disagreements between Rise, Gwyneth, Spire, Tycho, etc. And so we might, I think it's unlikely, but it's possible that we get to a future where we not only extend the network effect of Ethereum into like each of these base rollup clusters, but we lose that network effect between the clusters, which I think would be a great coordination failure.
Do we have time for one more?
Yeah, we have time.
Okay.
Vitalik, I think, recently not proposed, but maybe came up with this thought process where he said, maybe we should go absolute degen regarding rollups, and you come up with a model where Ethereum, the way we see today, kind of transforms into a very basic, minimal, let's say, RISC-V compiling, or have a framework where you deploy or verify basically ZK proofs. And the Ethereum, the execution engine, basically becomes a rollup itself to this meta Ethereum, whatever you call it. In that model, how do you foresee base rollups and some of the other rollups that are there and that will evolve over time, and how that network effect might flow in?
Yeah, so Justin and Vitalik both talk about this quite a bit. Justin's Beam Chain talk got a little bit into this. We can snarkify the execution layer to at some level. We can also add a ZK VM opcode to the EVM to enable what we call native rollups. The terminology is confusing, but my understanding is that native rollups apply only to execution. It's an alternative to doing fraud proofs or like the kind of ZK proofs that people do today. And in the end game, we will see that execution transitioning. That is still independent of sequencing, though. So you could have based native rollups. You could have native rollups that are not based, or you could have based non-native rollups, right? And so it's hard to tell. I think native rollups will scale us to, I don't want to say infinite gas, but like tons of gas, right? Especially with some of the designs like stateless validators, make it a little more effective and practical to get there. Ethereum layer 1 research is never something I like to speculate about, because I've been wrong in the past, and unfortunately, the cryptography required to do that is just not well understood. Like we don't, at this point, we don't understand where the bottlenecks are in proving, and just kind of the second order effects of adding a ZK VM opcode to Ethereum. So kind of a non-answer, but.
All right. Are there more questions? Or okay. So, okay. Actually, I have one more question. So, one thing to think about is, because you can do synchronous composability directly between rollups, right? The key advantage of base rollups that you presented today is that you can enable synchronous composability between L2 rollups and the L1, right? And base rollups are uniquely helpful in that, because to do synchronous composability, you need to have a coordinated builder, right, or a shared sequencer. And there's only one builder for the L1 block, so that needs to be the builder for the L2. What do you think about the future role of the L1 versus the L2? If all applications move to the L2, if all assets sort of move to the L2, and the layer 1 is just sort of used as a settlement layer and used for data availability, etc., then why not just have synchronous composability between L2s and not worry about synchronous composability with the L1?
Yeah, great question. So just kind of summarize and like put it into my words. We're at a point in the Ethereum roadmap where it's very possible that layer 1 becomes not the home of DeFi, but the home of nothing, right? Settlement, maybe. A little bit of DA here and there. And layer 2s have all of that network effect. I think that's totally a possible and plausible future. And in that case, I still think synchronous composability is valuable. But of course, you don't need base sequencing to do it. And so in that world, I would say base sequencing for the most part has failed. We have failed to like keep the layer 1 network effect where it is. We have distributed it to layer 2s. It's very possible that those layer 2s are very aligned and you may have an EF layer 2. It could be a nice feature. One thing that I really want to highlight is as we move everything away from the layer 1, we lose the properties of layer 1 that you can only get on layer 1. So it depends on the design of like Fossil or Braid or whatever, but it's possible that sensitive resistance will be very hard to transfer to a layer 2, even with the base rollup. Inclusion guarantees, liveness guarantees, things like this that might only be possible on layer 1. And perhaps the strongest point is Ethereum staking will always need to be on layer 1. So Steth, all of your liquid staking tokens, the ledger of last resort will always be Ethereum layer 1. And of course, native ETH itself will always be on layer 1. So a bet on like the network effects of the token ETH being a permissionless property rights system versus network effects like disseminated to Ethereum layer 2s. Yeah.